Which statement explains why the gases propane, C3H8, and carbon dioxide, CO2, diffuse at the same rate at room temperature and pressure? So, both are denser than air, both compounds contain carbon, both molecules contain covalent bonds, they have the same relative molecular mass mR. So, we know that if we are looking at why they diffuse at the same rate, we'll need to look at either something being the same between these two compounds, and they are being denser than air is quantitatively says nothing about being the same. Both compounds contain carbon. Well, containing carbon doesn't mean they should diffuse at the same rate, so this is also wrong. Both molecules contain covalent bonds. Well, doesn't really explain about diffusion, because we are talking about here diffusion, and it is at the same rate. So covalent bonds doesn't really explain anything. They have the same relatively molecular mass mR. That's correct, because actually we are talking about rate of diffusion is being inversely proportional to 1 mR, which means, roughly speaking, you can think of it this way. There are molecules here which needs to diffuse from a high area of concentration of high area towards a area of low concentration, and the bigger the molecules, so think of it being very hard heavy potatoes which need to move to the same amount of space in the same amount of time. It's gonna take much more time. So in fact, the lighter they are, the better, and the lighter they are means the lower the mR, means the higher the rate of diffusion. So C3H8 here in this case is, we'll have to check out their molecular mass. C3 is 12 times 3 is 36, plus 8, 1 times 8 is 8, 36 plus 8 is 44. And then for CO2, calculating the mR of CO2, C is 12 times 1 of them is 12, and then O is 16, and we have 2 of these, so that's 32. 12 plus 32 is equal to 44 again. So we have again 2 times 44, and so this is correct answer D.